So this is where we stopped. Number 4. Okay, we're dealing with first order linear differential equations. This is normally question 4.1 in your exam, and this is chapter 4 in your textbook. Right, so what we need to do here is always rewrite the equation in standard form. So our standard form here is dy over dx plus p times y is equal to q, and pay attention to the fact that the coefficient of dy over dx must be positive 1, and it must be in this order. Right, so here we got two problems now. Is that we have 3 terms, 1, 2, 3 terms on the left hand side. The standard form only has 2 terms on the left hand side. Can you see that? So what we can do is we can take this negative 2 to the right. So we have sin x times dy over dx plus y cos x is equal to 2. You can see our standard form only has 2 terms on the left. Now the next thing to take note of is the coefficient here is not a positive 1. So what do? We manipulate it. We need to divide both sides. So we're going to divide the left hand side by sin x, because I want sin x and sin x to cancel. Whatever I do on the left, I must do on the right hand side. Okay. So now sin x over sin x here, that will be 1 times dy over dx plus, and then I have cos x all over sin x times y, because remember I'm dividing term 1 by sine, term 2 also by sine. Every single term has to be divided. Oh, it's the same as multiplying by 1 over sine on both sides. And here I just have 2 over sin x. So now, this can, if you want to, you can simplify it further. Cos over sine from your trigonometry is cot. 2 over sine is 2 times 1 over sine, which is cosine. Right, so now we need to identify P and Q. So P is equal to cot of x, Q is equal to 2 times cosec of x. So now we need to work out the integrating factor. So your integrating factor is given by the formula e to the integral of e to the power integral of p dx. So we will substitute into this formula. So here my p is cot, so that will be just cot x. Now you need to integrate cot. You go quickly to your formula sheet. If you don't know the formula, you integrate cot. It's going to be ln absolute value of sin x. Okay, we integrate cot. It's ln of sine. And now we know that e to the power ln f of x is equal to f of x. This is coming from your log laws, okay, which I can explain to you. E to the power ln f of x is always equal to f of x. So e to the power ln of sin x, in this case f of x is sin x. So this is equal to just sin x. So now we have our integrating factor. So now we will substitute into the formula. So you go to your formula sheets, page 7. So the formula is y, if it's y times your integrating factor is equal to the integral of q times your integrating factor dx. So we have y times sine x is equal to the integral of q, my q was 2 cosec x times your integrating factor there, which is sine x dx. And now you can see that we need to integrate here. So we need to simplify first. So we should have just left it as 2 over sine instead of writing it as cosec, because now we will have to change either sine to 1 over cosec or cosec to 1 over sine. It doesn't matter, it will cancel anyway. So let me change cosec to 1 over sine. So now you can see that sine and sine will cancel. So you end up with just 1. And then remember okay, let's integrate this while we're here. Integrate your 1, you're going to get x, so that will be 2 times x, which is 2x, plus c. Don't forget your left hand side. Your left hand side is y sine x. Right, so this is your general solution for the first one. Right, let's deal with number 7 now. So what do we notice here? We have our 2 terms on the left hand side. Right, so the coefficient of dy over dx is already positive 1. So the only difference here is that your standard form has a plus. So if you want to, you can write down a plus. So therefore this becomes minus 1 over x times y. If you multiply a positive times a negative, you get back to your negative. Right, and then we have x squared cos x. So now we can identify our p and q. So my p here is minus 1 over x, and q is equal to x squared times cos x. So now we work out our integrating factor, which is e to the power the integral of p dx, which is equal to e to the power, and then p is minus 1 over x. Right, we did one like this here previously. So you can integrate this. You integrate minus 1 over x. It's going to be minus, learn absolute value of x then. Now, be careful. It is not in standard form at the moment. In order for you to use the log law, you cannot use the log law at the moment because of your negative here. So this will be e to the power ln x all raised to the power negative 1. And now it's in standard form. E to the power ln f of x is equal to f of x. So this is equal to x to the power minus 1, which is the same as 1 over x. So that is your integrating factor. And now we substitute into the formula. Y times your integrating factor is equal to the integral of q times your integrating factor there. So it's y times 1 over x is equal to the integral of q. Where was q? There's q, which is x squared cos x times 1 over x dx. We need to simplify the right hand side here. So this will equal to just x cos x dx. And now we need to integrate x times cos x. So this is not an exact derivative problem, because the derivative of x is not x, the derivative of cos x is definitely not x. This is multiplication, integration by parts. You must recognize, you see, this is integration by parts. So the formula for integration by parts is f of x, g of x, minus the integral of g of x times f prime x. So you go to your priority list. From your priority list, x is number 3 and cos is number 5. So number 3 will be higher than number 5. So f of x will be x. G prime x is cos. So g of x will be the integral of cos, which is sine. So whatever you copy here, whatever you write down here, you will copy it here. That is your sine x. And if f of x is x, f prime x means differentiate x, which is 1. So that is integration by parts. So that's going to be x sine x minus integrate sine, that will be minus cos x plus c. You're done. So this is your general solution. You do not have to make y the subject. You can leave it like this. It's fine. Right, so here we got dy over dt. It's just that x is being replaced by t. So that shouldn't be a problem. The main thing is this in standard form? So we got two terms on the left, one on the right. Coefficient here is 1, so that's fine. We can identify our p. So p is equal to 1 minus t all over t. And q is equal to e to the power 2t over t. So now our integrating factor is equal to e to the integral of p dt. Don't write down dx now because we are integrating with respect to t, so it's dt. So this will equal to e to the power, the integral of p is 1 minus t all over t. We're integrating with respect to t. So this here you are used to integrating the difficult ones. So this is actually an easy one. The thing is, when you've been integrating the difficult ones for so long, then the easy one will get you confused. This is like an N4 type of integration. All you have to do is separate them into two fractions because they are not in standard form. So here, so this will be the integral. When I say separate, you will write it as 1 over t minus t over t. You can see that? My common denominator there is t. All I did was split it up into two fractions. So that will be 1 over t minus 1. T over t is 1. Now, simplification, there's nothing more I can do. I can now integrate each one with respect to t. So this will be e to the power. When I integrate 1 over t, it's like 1 over x. 1 over t, when I integrate 1 over t, it will be ln t. You're clear with that? When I integrate minus 1, it will be minus t. Now, so now you know that when you have this, remember, e to the power ln of f of t is equal to f of t, or e to the power ln f of x is f of x, same thing. Alright, so the problem here is we got the minus t here now, which is preventing us from applying the rule. So what do? We need to simplify further. So let's take this. So my integrating factor is equal to e to the power ln t minus t. That's at its current state. Now we can split it up and write it as e to the power ln t times e to the power minus t, because I'm splitting it up. Remember exponential equations, in n3 we can split it up. The bases are the same. When I'm multiplying and the bases are the same, write down the base once, add the exponents. You can see that. So therefore, this is the same as e to the power ln t all divided by e to the power t. Now, we're interested in this part here. E to the power ln f of t. So there's e to the power ln t. My f of t is t. So e to the power ln t is just t. So simplified, that will be e to t over e to the power t. That is my integrating factor. This is more like an exam type question, this one. Okay. You have to simplify a lot here. And if one mistake in the beginning, obviously you're going to get stuck here. So now, once you do this, now our formula, so it's going to be y times your integrating factor is equal to the integral of q times your integrating factor dt. Remember, don't forget we're integrating with respect to t. So now it's going to be y times your integrating factor. What is my integrating factor? It is t all over e to the power t is equal to the integral of q. Where was q? Q was e to the power 2t over t. And my integrating factor is t all over e to the power t dt. And now you can see it's going to work cancel nicely here. So what happens here is t and t cancel. So you end up with e to the power 2t divided by e to the power t. So there's it here, e to the power 2t divided by e to the power t. And this is exponent laws. When the bases are the same and you are dividing, you write down the base once and then you subtract top exponent minus bottom exponent. 2t minus t is just 1t. And then the last part is the easy. Look, certain examples, the last part is difficult to integrate. But this one, the last part is easy. It's just that the beginning is difficult. You can see that. So e to the power t is just e to the power t plus c. And that is our general solution for this one. Right, so here I'm choosing number 10 from the exercise, the same exercise that we've been dealing with. So now, our standard form, remember the standard form? Is dy over dx plus p times y is equal to q. So now, the only difference is that the letters are not the same. Instead of y is being replaced by r here, you can see that. So there's your dy, it's dr, there's your y here, which is r, and then x is being replaced by theta. That's all. Okay, the rules are all the same, it's just that we're using different letters. Now, first thing is standard form. Our standard form here is dy over dx plus py is equal to q. So here I can write this as dr over d theta plus minus 1 times r is equal to sine theta. Remember, this y is now r. So what I want is a positive, and I want to write down p within brackets. So now I can identify my p. So p is equal to minus 1 And Q, the right hand side here is sine theta. Now, the integrating factor. So, the integrating factor is equal to e to the integral of p. Now, what are we integrating with respect to? D theta. So that will be d theta. Normally you write down dx. Okay. So it's d theta. So this is going to equal to e to the integral of minus 1 d theta. So when you integrate to minus 1, what do you get? You're just going to get minus theta. It's like if I had dx here, then that will be minus x. So I got e to the power minus theta. Now, this is my integrating factor. Now we will substitute into the formula. So your formula is normally y times integrating factor is equal to the integral of q times your integrating factor dx. Okay, now this is based on y and x, but in this case we have r and theta. So you will write down r times your integrating factor is equal to the integral of q times your integrating factor d theta. It's just that the letters have been changed. Alright, so now we got r times your integrating factor there is e to the power minus theta is equal to the integral of q. What was q? Q was sine theta times your integrating factor is e to the power minus theta d theta. Now, remember that after you substitute, we're back to our N5 type integration, which is also repeated in N6. We got an exponential function times a trig function. This is integration by parts. And not just any example by integration by parts. This, if you remember, we call it the special cases. This is a special case example. So you can see the difficulty level with these type of examples is much higher than chapter 2, because you need to think every step of the way. Right, so you need to see what is this? What type is it? This is integration by parts, special case. Now, okay. What is the formula? The formula for integration by parts is f of x times g of x. But what are we integrating with respect to? To theta, so we're going to call it f of theta, g of theta, minus the integral of g of theta times f prime theta d theta. And now my f of theta, which one is my f of theta? So now obviously you need to remember your priority list. Okay, you have to have all that before you come to chapter 4. Priority list, but anyway, this is also an N5 problem. So from your priority lists, E is number 4, sine is number 5. So we normally choose what's higher up. So what's higher up here is e to the power minus theta. Now this will be g prime. So to find g, you need to integrate sine, which is minus cos So whatever you write down here, you will copy down here too, which is minus cos theta times f prime theta. So f of theta was e to the power minus theta. F prime theta means differentiate, so that will be e to the power minus theta times the derivative of minus theta, which is minus 1 d theta. So here, this is minus e to the power minus theta cos theta, negative times negative times negative is a negative. The integral of cos theta times e to the power minus theta. Now, if you remember the special cases, we need to use the formula twice. We only used it once, so one more time. So let's copy down the formula again, which is f of theta g of theta minus the integral of g of theta times f prime theta d theta. Right, so let's see what we have here. R e to the power minus theta is equal to minus e to the power minus theta times cos of theta minus, now again remember the second time we're using the formula, so we follow the same priority list. So my f of theta is going to be e to the power minus theta. Then this is going to be g prime theta. So g of theta, you integrate cos, you should get positive sine theta. So that's f times g minus the integral of g here, which is sine theta, and then f prime theta is e to the power minus theta times minus 1 d theta. Now remove the brackets. So minus e to the power minus theta cos theta here minus e to the power minus theta sine theta here. Negative times negative times negative is a negative. The integral of e to the power minus theta sine theta d theta. Now, what do we do after you apply the formula twice? Remember, we need to get our like terms on one side. So, be careful now. This here is equal to this part here. Okay, so be careful how you're going to write this. So let me just write it down for you properly. So, the integral of sine theta e to the power minus theta d theta is equal to this part here, which is minus e to the power minus theta cos theta minus e to the power minus theta sine theta minus the integral of e to the power minus theta sine theta d theta. So the special case example, after you use the formula twice, you end up back to the question. Always. Okay. So what do? Take your like term onto one side. So if I take this to the left hand side, I'm going to have 2 of the same thing. 2 times the integral of sine theta e to the power minus theta d theta is equal to whatever we have here. So all I have to do now is divide. So the integral of sine theta e to the power minus theta d theta is equal to 1 over 2 times e to the power minus theta cos theta minus e to the power minus theta sine theta, and now we can put down our plus c. But now remember, let's go back. Our left hand side is, let's here, don't forget that. So therefore, we got r e to the power minus theta is equal to half minus e to the power minus theta cos theta minus e to the power minus theta sine theta plus c, and this is called the general solution involving the special case. I told you that anything can come out. You have to think every step of the way. After you do your substitution, then you can see this example here, the last part is quite long. Other examples, to find the integrating factor will be difficult. It depends. Okay, so have a look at this, take it down. I'm going to deal with the next one. Right, our next example, number 12. So we're back to y and x. The previous example was r and theta. So clearly this is not in standard form because we have the 1 minus x on the left in front of your dy over dx. So what we can do is divide both sides by 1 minus x. Remember, you need to divide every single term on the left, every single term on the right. Whatever you do on the left, you must do on the right. So here we got 1 times dy over dx plus 1 over 1 minus x multiplied by y is equal to, here you've got 1 minus x to the power 7 over 2 divided by 1 minus x to the power 1. So this can be simplified to 1 minus x, 7 over 2 minus 1 is going to be 5 over 2. You have to know your exponent laws. You have to realize that you have to use exponent laws here. You can see that. Because the bases are the same. When the bases are the same and you are dividing, you write down the base once, top exponent minus bottom exponent. Right, on the left hand side, there's nothing more to do. You also have to realize that you have to write this as a fraction here, times y. Now, we can identify our p, which is equal to 1 over 1 minus x cubed, which is equal to 1 minus x to the power 5 over 2. So our integrating factor is equal to e to the integral of p dx. So this is equal to e to the integral. We're going to substitute. That's 1 over 1 minus x. And now this is what I am interested in. Can you integrate this here? Because this is the n5 one. Can you integrate? So I'm going to give you 1 minute to make sure you try and do this. And then let's see where the mistake is here. Right, so this is the point of interest at the moment, which is this part here. So let me just rewrite it. Let's rewrite it here. So we have the integral of 1 over 1 minus x dx. Straight away, you should recognize that this is a fraction where you have f of x in the denominator. There's your f of x. And then f prime x in the numerator. Now let's see. Does this satisfy f prime x over f of x? Not 100%. But we can manipulate it by inspection. So if f of x is 1 minus x, let me just do it in the next. Okay, let me do it here. Then f prime x means differentiate this. So the derivative of 1 minus x is minus 1. So now it is an exact derivative. So now remember that I need to also divide or multiply in this case So there's my k now. Can you see that? There's my k, which is minus 1. There's my f prime x, which is also minus 1. F of x, which is 1 minus x. Why am I doing this? Because negative times a negative will give you the original positive 1 which was there. That's how you do inspection. Now, once this condition has been satisfied, then the answer is always k times ln absolute value of the denominator plus c. That is our n5 integration. So let's do it here. So let's go back to our problem. Okay, going back to n6. So that's the integral of minus ln of 1 minus x. You're clear with that? Now, we need to remember when we have e to the power ln, we need to simplify. Remember that e to the power ln f of x is equal to f of x. That is our log laws. Okay, so in this case, it does not satisfy this condition. Right, you must pay attention to the detail. Okay, it looks the same. It's not the same. It appears to be the same, but there's a small difference. The difference is that this is a positive 1, that is a negative 1, so it means it is not the same. Okay, so therefore we need to manipulate this here. So now this is equal to e to the power ln 1 minus x to the power minus 1. Can you see that? Now it satisfies the condition. Now your f of x is this part, e to the power ln, the coefficient is positive 1. Now it can be written as 1 minus x to the power minus 1, which is the same as 1 over 1 minus x. Can you all see that? So this is your integrating factor. Now we substitute into the formula. Y times your integrating factor is equal to the integral of q times your integrating factor dx. So that's going to be y times your integrating factor there is 1 over 1 minus x is equal to the integral of, what is your q? Where was q? There's q here. Right, so we have to make sure you can see how we worked out q here. If q was wrong, obviously this is also going to be wrong now. That will be wrong too. So my q is 1 minus x to the power 5 over 2 times your integrating factor, which is 1 over 1 minus x. This is like an exam question, this one, definitely. Right, you can see the difficulty level here. You can get stuck at any point, even in the beginning. Right, so maybe if you work this out, you could get stuck over here or over here. So now, what do? Simplify. The bases are the same. I'm dividing. So I will write down the base once, and I will subtract the exponent. 5 over 2 minus 1 is going to be 3 over 2. Now, another n5 integration problem. So I'm going to give you 2 minutes again to do this before I do it. It's very important that you try it out. This is an n5 type problem at the end also. Alright, so this was the point of focus. Again, our n5. Again, nothing too difficult here. It's just that now it's within this problem here, our differential equation. So this we're done with. This here applies. Where is it? Here. Okay. So now, what do we have here? We have this type k f of x to the power n times f prime x dx. This is the first type you deal with in n5. Right, it's multiplication. F prime x is here, f of x is there. So if this condition is satisfied, then by inspection the answer will always be f of x to the power n plus 1 over n plus 1 plus c. Now, let's check. Is this condition satisfied 100%? Let's check. Alright, so here is my f of x. Here is my power n. You can see that. Let me do it in the next step again. So you must see what was there originally. Alright, so let's write this down. Here is my f of x. Here's my power n. F prime x supposed to be here. What is the exact derivative of 1 minus x? Just minus 1. So now, if I put a minus 1 there, that means I need to multiply or divide, same thing, by minus 1. So now what do I have? K, there's my k there. F of x to the power n, f prime x. Now, we can apply the formula in one step, one time. So the answer will be k, which is minus 1. And then you got your f of x which is 1 minus x to the power n plus 1. So you're gonna go 3 over 2 plus 1, which is gonna be 5 over 2 divided by 5 over 2 plus c. Alright, so that let me just simplify this, but the main job is done. Right, that's the main thing. So we got y, this is general solution times your 1 minus x there is equal to minus 2 over 5 times 1 minus x to the power 5 over 2 plus c, which is the same as minus 2 over 5, and then I can rewrite it back in third form, like how it was given to us. So this 5 is here, and the 2. So the 5 is here, and the 2 is there. You can see that? So check properly.